My name is Dev Comboy, and today we're going to be talking about big data. So what is big data? Big data is a broad term, and it's a very hot term these days, and it refers to data sets, so pieces of information, and that could be any variable. Facebook users, for example, there's billions of Facebook users, maybe just names. They're huge. I mean, there would be a huge amount of data. So it's a data set. Big data is a broad term for data sets that are so large and complex that traditional applications, processing applications, are kind of not even able to process whatever it is. So if you think about a byte, a song could be what, 10 megabytes. Then you think about a gigabyte, which would be, a couple gigabytes would be a movie. These are terabytes, thousands of gigabytes, and some of them exabytes. I mean, these are insane amounts of data, like millions and millions of gigabytes of data. And a lot of this is just text. So in order to process and just even, look at this or visualize it, there are special applications that need to be developed for them. So these ones and zeros add up to billions and billions and billions of ones and zeros, possibly even trillions, and they're so large that we don't know what to do with them. So the first problem is defining what to do with them, and then moving on to kind of what we should do with them. So like analyzing them, capturing it, searching it, sharing it, storing it, transferring it, visualizing it. That could really help us, in terms of finance, in terms of combating crime, spotting trends, diseases. These are all huge benefits of being able to look at data this large. So they grow in size because they're being gathered through very cheaply. You can code a script in a phone to say every new creation of an account will just be put into this database. I mean, after billions of this happening at a time, it becomes such a large amount of information that it's hard to process. So that is kind of the term for big data. Where does it live? They live in relational database management systems, so our DMSs. They live in data farms, servers, basically. So huge aggregations of hard disks and hard drives in giant rooms that are super cooled via nitrogen. Here's a visualization of kind of what that looks like. And this little corner is the tiniest little bit, and each one of these represents a different drive. So this network is an insane amount of processing. And I mean, this is, ironically, this is kind of an interpretation of what big data is in terms of how to store big data. So it's an interesting look at both the application and what it actually looks like. So that's why I picked this photo. So who has it? These top 10 big data companies, there's tons and tons of people that have it. Facebook. And this ties kind of in why it's relevant to us. There's a lot of information that's being aggregated about us as human beings, and in a digital age, we're constantly on the internet. A lot of this information is stored without us even knowing it. And this information can be accessed by pretty much anybody, and we don't really understand what that really means. So here's a little Wordle describing a few of the terms in relation to big data. So how much data is stored on the average individual? A lot, a very large volume. One survey even estimated that there are 40 gigabytes of data stored on each human being. So any photo you've uploaded, pictures of you in public, via facial recognition, phone calls you've made, text messages, financial documents you submitted, things that have gone through bigger companies, things that have gone through the government. A lot of this information is stored, and people don't really realize it. They live in data farms. This process of thousands of millions of basically space. And here's a picture of one where it's basically these giant, huge servers. So how much data they have? Sometimes it's more than terabytes. Sometimes it's exabytes. Sometimes it's huge, huge interpretations of them. So this really is relevant to us. This is Obama here talking about great. Here's a great photo of Obama running through the ocean. Really relevant, but it talks about his big data research, and he says, by improving our ability to extract knowledges and insights from large and complex aggregations of digital data, basically, we can really enhance our process and the pace of our discovery of both us as humans and basically how we move forward as a society. So here are some characteristics that define big data: the volume, the variety, the velocity, the variability, the veracity, and the complexity. And these are all terms that really describe, the volume being how much, the variety between, what data in that farm really is, whether it's text or pictures or how to analyze that data, the velocity, the speed at which data is generated and processed to meet what lie ahead, the variability, the inconsistency of the data. Sometimes data can't be interpreted the same way. So, that can cause a hindering in how we process and manage it. And then the veracity, the quality, how what does that information really say something, and the complexity. And I mean, you're talking about totally different types of information all being processed by a single unit. Then what are we really looking for? So that's supposed to say manufacturing, big data and manufacturing, not manufacturing, but basically this is the greatest benefit. Providing infrastructure and transparency for the manufacturing industry. We can now basically tell whether our products are inconsistent or not of quality. And here's the 6 C's commonly discussed amongst big data experts: connection, cloud, cyber, context, creation, community, and customization. And this basically shows you from the start to finish how it's aggregated, sensed, computed, and then shared and basically valued. DARPA is a good example of big data and how the government is using big data. It's the research project that the government is using now to kind of take information about us and the Defense Advanced Research Projects Agency. So it's part of the U.S. Department of Defense, and it's kind of finding these emerging technologies and using them for our military. So ever since Sputnik 1 in 1957, DARPA was like, okay, wait, we need to take this frontier and be at the cutting edge of this stuff. So protect people, prevent technological surprises like Sputnik, who would, that really gave them advantage of us in war and other things. So yeah, this is another visualization, but big data, very, very important topic today, and we should continue to explore the benefits of it.